This is part of problem 1.7.46. We have our function for our total sales. T of x is 12/5 plus 48 over the quantity 5 times 3x plus 1 squared. And we're supposed to find the derivative of t evaluated at x equals 1, or t prime of 1. First, I'm going to rewrite my function t of x slightly. So 12 over 5 plus I'm going to pull out this 45 over 5 just as a coefficient, so I don't have to worry about it. And instead of 3x plus 1 in the denominator, I'm going to just write it as the power of negative 2. Now to find the derivative. First, the derivative of a constant. The derivative of a constant is 0. Plus, now my coefficient I can just pull out, I don't have to worry about it. Now for this piece right here, I need to use the general power rule, or the chain rule. I like to think about this with boxes. So I'm going to put a box around everything inside the parentheses, this 3x plus 1. So now you kind of think about it as like some quantity in a box raised to the power of negative 2. So when I'm using a power rule, or the general power rule, I'm going to bring down the power. So let's bring down the negative 2. Keep everything in the box the same, so 3x plus 1. And then when we take the derivative, we drop the power by 1. So from negative 2, we'll drop it to negative 3. Now the chain rule, or the general power rule, says take the derivative of the outside and then times it by the derivative of the inside, what's inside the box. So inside the box we have 3x plus 1. The derivative of that would just be 3, because the derivative of 3x is 3, plus 0, because the derivative of 1 is 0. And so this is our derivative of the inside. So to simplify slightly, we have here 48 over 5 times negative 2 times 3 times the quantity 3x plus 1 raised to the negative third power. And I could simplify some more if I wanted, but we don't really need to. Let's just go ahead and plug in x equals 1 right now. So we have 48 out of 5 times negative 2 times 3 times 3 times 1 plus 1 raised to the negative third power. And if we plug all of this in, we get negative 0.9.